Chapter 4.2, Angles of Triangles. In this chapter, we're going to solve for the measures of each of the angles in a triangle. We already know that the angles all sum up to be 180 degrees. In the first problem, we're given a diagram and asked to find the measure of each of the number angles. To find the measure of angle 1, I know that the three angles in a triangle have to add up to be 180 degrees. So I'm going to take and add the other two angles together and subtract them from 180. So the measure of angle 1 is 180 minus the sum of 43 plus 74. So that's 180 minus 117, which gives us 63 degrees. I know that angle 1 and angle 2 are related. Angle 1 and angle 2 are vertical angles, so the measure of angle 2 equals the measure of angle 1, which is 63 degrees. To find the measure of angle 3, I'm going to sum the other two angles together and subtract them from 180. So the measure of angle 3 is 180 minus the sum of angle 2, which is 63 degrees, and 79. So that's 180 minus 142, which is 38 degrees. So I have the measures of all three angles. In the next problem, we're asked to find the measure of angle 3. To do that, we have to find the measure of angle 1 first. So the measure of angle 1 would be 180 minus the sum of 38 and 67. So it would be 180 minus 105, which would give us the measure of angle 1 is 75 degrees. Which tells us the measure of angle 2 is also 75 degrees because they're vertical angles. To find the measure of angle 3, it'd be 180 minus the sum of angle 2 and 48 degrees. Which would give us 57. The next theorem is something that gives us some information that we can use to solve problems in a faster method. We know that, or we're told that, the exterior angle is equal to the sum of the two remote interior angles. So the measure of angle 1 would equal the measure of angle A plus the measure of angle B. In the first problem, we're asked to find the measure of angle FLW. So we're asked to find the measure of this, which is an exterior angle. So I know that the exterior angle is equal to the sum of the two remote interior angles, the angles that do not touch the exterior angle. So it would be x plus 32. Subtracting x from both sides, I would have x. Adding 48 to both sides, I would have 80. So I know that x equals 80. I was asked to find the measure of FLW. So that would be 2 times 80 minus 48, because I plugged x into the expression that we have for the measure of that angle. So that would be 112 degrees. In the next problem, we're asked to find the measure of this exterior angle, and we know it is the sum of the two remote interiors, the interiors that do not touch it. So 3x plus 10 equals x plus 90. So 2x equals 80, and x equals 40. Plugging this back into the expression that we have for the angle that we want to find, I have that the measure of angle ACD equals 3 times 40 plus 10, which gives us 130 degrees. The next two corollaries that we've spoken about already. That if we have a right triangle, and so a right triangle means that one of the angles equals 90 degrees, then the other two angles have to sum up to be 90 degrees. So that means that the other two angles in a right triangle are acute angles, and they're complementary. We also spoken about the fact that there can only be one right angle and one obtuse angle. There can't be two obtuse angles in a triangle because that would add up to be more than 180. And there can't be more than one right angle because two right angles would add up to be 180, which means, again, we wouldn't have a triangle. So we want to find the measure of each of the number angles. So if I look at angle 1, the measure of angle 1 would be the sum of the two remote interior angles. So that would be 48 plus 56, which would give me 104 degrees for the measure of angle 1. The measure of angle 2, well, 2 and 1 are a linear pair, and a linear pair is supplementary. So to find the measure of angle 2, I would take 180 and subtract the measure of angle 1, which is 104 degrees, and I would get 76 degrees. To find the measure of angle 3, I know these three right here form a line. So to find the measure of angle 3, I can subtract the 90 degrees and the 48. So the measure of angle 3 would be 180 minus the sum of 90 plus 48. So 180 minus 90 plus 48 would be 138. So the measure of angle 3 is 42 degrees. The next angle I want to find is the measure of angle 4. And if I look at this right triangle right here, I already know that the measure of angle 3 is 42 degrees. So to find the measure of angle 4, the two non-right angles have to be 90 degrees, have to have a sum of 90 degrees. So I could do 90 minus 42, which would give me 48 degrees. To find the measure of angle 5, I know that these two angles are complementary, that they have to add up to be 90 degrees because this is a right triangle. So to find the measure of angle 5, I would do 90 minus 41, which would give me 49 degrees. So 90 minus 41. So we're going to look at this picture and again use the knowledge that we have to find the measures of each of the number angles. So to find the measure of angle 1, it would be 180 minus the sum of the other two angles. So that would be 180 minus 45 plus 85. So minus 130, which would give us that the measure of angle 1 is 50 degrees. Since angle 1 and angle 2 are vertical angles, we know that the measure of angle 2 equals the measure of angle 1, which is 50 degrees. To find the measure of angle 4, I'm going to do that one first. So the measure of angle 4, I know that these two here are a linear pair. So 180 minus 135, which gives us 45 degrees. So this one's 45 degrees. This one's 50 degrees. I know that this right here is an exterior angle, and I know that these two right here have to sum up to be that. So to find the measure of angle 3, I would do 135 minus 50 degrees, which would give us 85 degrees. Now the measure of angle 5 is the sum of these two remote interiors. So it'd be 75 plus 45.
Are you